All right, so let's start using our newfound knowledge for a problem. The combined verbal and quantitative reasoning scores on the GRE is normally distributed with a mean of 1066 and a standard deviation of 191. For those of you that have no idea, the GRE is sort of like the SATs, but for graduate students. I believe it's run by the same company that makes the SATs, but don't quote me on that. Anyway, suppose n equals 15 randomly selected students take the GRE on the same day. What is the probability that a randomly selected student scores between 900 and 1100? Well, because it's talking about a randomly selected student, that's really talking about one student, correct? Correct. All right, so if you're looking at one student, this is the distribution right here. I know it's a little bit low on the graph, but bear with me, there's a reason. Okay, so if I wanted to know the area between, they said 900 and 1200. Hold on, let me find the right one. There it is. The standard deviation is 191, in case you're wondering. All right, and so it was 900 to 1200. I'm not going to calculate it here. I'm just going to add the graph and say, okay, there it is. Ooh, we don't want nearly that big of a graph. Just want a quick sketch. There we go. All right, now how big is that area that I just found? Well, I could find that with Excel. All I'd have to do is, well, pretty much what I did here, right? It's, it was 1200. Okay, so 1200, norm dist 1200, where the mean was 1066, standard deviation is 191, true, minus, and then now take 900, the mean is 1066, standard deviation is 191, true. So you're taking the higher value minus the lower value, if you will. There. I have reasons for doing that. Never mind. Okay, so it's 0.5611. Oopsie, I didn't like that. There we go. And in case you want to just see it, I'll just copy and paste the formula in so you can get kind of a glimpse of it. Basically, you're taking one normal curve value, the one for the right guy, minus the one for the left guy. And if you take that minus that, you're going to get this little striped portion in the center. Make this smaller because I really don't need it that big. All right, now what if we look at a random sample of size n equals 15? Well, we know the shape equals normal because we were told that the distribution of the population is normal. If the population is normal, then the sampling distribution of sample means, is also normal regardless of the size of n. The center is mean of x bars, which is equal to 1066. Okay. Now the spread is sigma sub x bar, which is 191 divided by the square root of 15 in this example, which I happen to have already calculated over here with Excel. There it is, 49.316 roughly. Cool. Got our mean, got our center, got our spread, everything's good. Shape, center, and spread, not mean, center, and spread. Okay, so what about the probability? How does it change when we're dealing with 900 to 1200 now? Well, let me get the picture up again. Let me add in the other curve. Hold on, I gotta find it. There it is, look at that. That big checkerboard, all of that. All right, so let me copy. Now you can see why I made that curve so white on the top before, and paste. All right, now how does you find the probabilities? Well, you do the same thing you did before, but instead of 191, you do 191 divided by the square root of 15. And you do it over here to the other one as well. It's going to be a large number, right? There it is, 0.9963. Quite large, which makes sense because most of that curve is underneath there. I mean, look at that checkerboard. Almost all of it's there. And that's it. We've solved that problem for ourselves.